Today we're going to be doing function composition. So first thing we're going to look at is what direct substitution means. I'm not really going to give you the definition, just kind of, explain what it means. So direct substitution is where you plug a number into the appropriate function. So direct substitution, you're plugging a number into the appropriate function. So if you look here, we have an f of x function and we have a g of x function. So we've got f of x and g of x. So you're going to have to look at the examples and see which one of those we're going to use. The first example, if you notice, is a g of 2/5. Usually it's g of x, so that's just telling me that x, my x value in this problem, is 2/5. Alright, so let's go ahead and start plugging this in. The problem is 4x squared. So instead of the x, we're replacing the x with 2/5, so 2/5 squared, minus 2 times 2/5 plus 7. Alright, let's start simplifying. First thing, please excuse my dear Aunt Sally tells us to do, is to use parentheses or exponents. So I'm going to leave the 4 alone, and I'm going to do 2/5 times 2/5 to give me 4/25. Minus, if I multiply this, remember that's really 2/1, so 2 times 2 is 4, 1 times 5 is 5, and then I have plus 7/1. Just make them all fractions. First fraction is really 4/1 times 4/25, so it's 16/25. Now I want my next fraction to have a denominator of 25, which means I'm going to have to multiply the 5 times the 5 and the 4 times the 5. So minus 20/25. Again, the last fraction I want to have a denominator of 25, which means I'm going to have to multiply the top and the bottom by 25. And that gives us 175/25. 16 minus 20 is -4. -4 plus 175 is 171/25. Make sure you check to see if that reduces. It does not, but y is equal to 171/25. So my x value is 2/5, my y value is 171/25. Going on to b. b is asking for f of -7/4. The f function is a little bit smaller there. It's 2x plus 10. So instead of the x value, remember our x value this time is -7/4. So I'm going to do 2 times -7/4 plus 10. Let's change that 2 into a fraction. So 2/1, -7/4. See if you can cross simplify. I have the 2 and the 4 are both divisible by 2, so it becomes a 1 and a 2. 1 times -7 is -7. 1 times 2 is 2. And again, keep these as fractions. We'll change the 10 into 10/1. Remember, I need common denominators, so I'm going to multiply my second fraction top and bottom by 2. So I've got -7/2 plus 20/2 to give me 13/2. So when x is -7/4, y is 13/2. Alright, the last example, we're going back to g. So this time we're going to replace all the x values with a -3. So I'm starting with 4, -3 squared, minus 2 times -3, plus 7. Be really careful with your negative signs. This 4, I'm not going to do anything with until I simplify the parentheses with the exponent. -3 times -3, or -3 squared, is +9. -2 times -3 is +6, plus 7. 4 times 9 is 36. 36 plus 6 plus 7 gives me 49. So they're not all ugly fractions. What this problem was telling us is that when x is -3, y is 49. Right, let's go on. Okay, composition of functions is when you substitute or plug one function into the other. Now, you could see this a couple different ways. We could have f of g of x, f of g of x which can also be written as, it looks like fog. It's F, a little o, G, and you usually put parentheses around that, F of G of X. That's a composition of functions. So what this is really saying is you're taking your G function and you're going to substitute the whole function into the F function wherever you see an X. Okay, you could also see it backwards and you could have G, oops, that looks like a weird G, G of F of X, which also we could represent as G of F of X. So they mean the same thing, just different ways to write it. In this instance, we're actually taking the F function, the whole function, and we're substituting it into the G wherever there was a X. All right, let's try some of these because it sounds a lot worse than it really is. Now, another way that I actually could have written this is I could have written it like this, H of K of X. So those mean the exact same thing, so I just wanted to kind of point that out. What we're doing here is we're going to take our H function, leave that alone. Now instead of K of X, look up here, K of X is the same as 2x plus 7. So I'm going to do H of 2x plus 7. So before we were just plugging in a number for x, now we're actually plugging a whole expression into x. So it's saying to look at the h function, here's my h function, and that really says 2 times x squared. Well, I don't want to put the x like it was up there. I want to replace it with 2x plus 7. Okay, and then this gets a little bit more interesting here. So, what this really says is it says 2 out in front, and then write 2x plus 7 twice. Alright, now you kind of have an option here. You're multiplying three things. If you have two binomials, you know binomials have two terms in it like these two do, we could, hopefully remember this, but FOIL them out or multiply them out. So, FOIL is where you do the first 2x times 2x, and that gives you 4x squared. And then you do the outsides, 2x times 7 is plus 14x. You do your insides, gives you another 14x, and finally you multiply the last term. 7 times 7 is 49. I put parentheses around it because there's still a 2 out front. Alright, I'm going to combine like terms. I still have that 2. I've got 4x squared plus 28x plus 49. Distribute the 2 to simplify it. 8x squared plus plus 56x. Make sure you distribute that 2 to everything, plus 98. Alright, and we just did our first composition of functions. We plugged the k function, we took this function, and we substituted it into the x for the h function. Alright, let's try another one. This says to do k of h of x. So, let me switch up my colors here a little bit. Alright, so we've got another way to write this is k of h of x. Whichever function is on the inside is what goes into the outside. So first I want to see what my h of x function is. H of x function is 2x squared. So I've got k of 2x squared. I just rewrote h of x. Now it's saying to go ahead and plug 2x squared into your k function. So if the k function is this, it's 2x plus 7. Instead of writing x, I'm going to replace it with 2x squared. There's really nothing to do except to multiply the 2 times 2 to get 4x squared. We're not really squaring anything. Plus 7. And we're done. We just substituted the h function into the k. Alright, last example. This one, let me erase some of my stuff here. We are plugging an h into itself. So it sounds kind of weird, but what we're actually doing is we are going to plug, let me get some, here we go. We're going to do take this h function, so I've got h of 2x squared. So I've got this. We're going to take 2x squared and plug it into itself. So I'm going to rewrite that function without the x. It's 2, that's where the x used to be, squared. Whatever's in the parentheses is what we're replacing it with. It happened to be 2x squared. Alright, if you want to write this out differently, I've got the 2 from in front, I've got 2x squared that I'm going to write twice. Again, you're just multiplying, so 2 times 2 times 2 is 8, and then count your x's. Or if you want to break it up a little bit more, you've got the 2 in front, 2 times 2 is 4. I've got 2 x's here and 2 x's here. We're adding those exponents to get 4 of them. And then 2 times 4 is 8. 8x to the 4th. Okay, another type of composition of functions here.